Hello, our project title is House Programming Robot for the Elderly, and we'll present Cluster Innovation Center. This project has been mentored by Dr. Harinder Pal Singh sir, and I am Pankaj Baranwal.
I am Ridwan Luthra.
I'm Utkarsh Mittal.
I am Vivek Patel.
Caring for old people was traditionally the responsibility of family members. However, in today's fast paced world, nobody has time to spend long hours with the elder members of their family. So, utilizing the advent of new technology, we wanted to make a robot that could help the elder people when they are alone. Since it can map the room, it knows the room, it can help them in reminding them to take their medications, it could get them a glass of water, it could also help them with trivial stuff such as reminding them where they kept their spectacles or their keys or even their cellular phones. In case of emergencies, it could also alert the immediate family members so that they can rush to their aid. So we welcome you to the future of elderly care.
Okay, this is our arena where we'll be running our prototype. In our prototype, we have put in a Raspberry Pi, we have an Arduino, we have 3 ultrasonic sensors, we have a Raspberry camera, we have 2 servo motors and a gripper arm, and we have 2 DC motors, we have position coders on each wheel. The position coders are used to make sure that the bot moves a certain distance or turns a certain degree. The ultrasonic sensors are used for 2 purposes. First, to detect if there is an anomaly. So basically, if there is an object that is not in the right location, the ultrasonic sensor could detect that, and using the servo, it would be able to place it in the correct location. Pick it up and place it in the correct location. These 2 ultrasonic sensors are used for self-calibration by the robot. So if there is some error in the position coders, these ultrasonic sensors will be used to eliminate that error. For interfacing with the servo, we have put in a Arduino because it's easier to interface Arduino with the servo. The Raspberry Pi is the base controller, which is controlling all the actions. The Raspberry Pi is giving commands to the Arduino, which will then control the servo. The Raspberry Pi camera is used in the first time the bot moves in the arena. It'll detect which digit it is and code it with the location of that object. Next time when we move the bot around in the arena, it would be able to process this image and know what is the correct location of that block and place it in the correct location. This is the entire prototype that we have for now, and you'll be seeing the demonstration later. And we have used for Raspberry Pi, we have used Python, and we have used OpenCV for all the image processing that we are doing, and that's pretty much it on the software base. We have used some libraries like RPI, GPIO, and GPIO0 for interfacing with different sensors and motors.
Well, this is our awesome cube bot, and it is moving in the test arena. Its task right now is to map the entire arena and test for obstacles. It will click the images of the obstacle, like right now it is trying to go to that 8. It will click but due to some calibration errors, I'll have to manually set it. Now, because the image can't be taken from this close, it will shift back, take the image, process, and know that that digit it just discovered is actually 8. So machine learning algorithms have been applied for that. Now that is a big calibration error. We'll try to avoid that in the future, but due to some sensors malfunction, we are not able to do that properly in this video. For the most part, it's working on its own with no white line sensors or any hard-coded data of any kind. If it were not for these calibration errors, it would have moved perfectly. See, now because the distance is less, it will move forward. Distance is actually more cool. It took the picture. Here is its camera. Now it's going towards this tree, taking a picture and drop.
we were first time interfering with Raspberry Pi and Arduino, so it was difficult to implement our idea with this electronic device. First we tried to implement all our ideas in Arduino, but we were not able to do all the tasks with Arduino, so we shipped from Arduino to Raspberry Pi. Then during our implementation, we fried one Raspberry Pi and also we fried one Pi camera. Then during image processing, we were not able to get the right reading from the real life object. So we have done some image processing with OpenCV. Then we use some machine learning algorithm. We implement SVM through it and resolve this problem. And our major problem was calibration. When we were using the position encoder, we were not able to get the right reading from the obstacle. When we using the board, it was not able to turn properly 90 degree, not it was able to move forward. So we have done some self calibration by using the ultrasonic to resolve this.
We have built a test arena which has certain blocks. When we place our robot in this area, it will first move around, going to each obstacle and mapping their current location. After that, it will randomly move in the arena, and if there is any block that is not in its correct location, the bot will be able to detect that and pick it up and put it in its correct location. We have used image processing to detect the digits of the block so that we can understand what is the object and where is it located, so that the bot can go and keep it in the right location and know whether it is in the right location or not. Apart from that, we have used a gripper arm to lift these objects, and all this can be extended to be able to recognize real life objects, and a better picking up mechanism and moving a mechanism can be put in place. Thank you. The total cost of this bot is 7,000. The main costs are Pi, the Raspberry Pi, Arduino and the camera board, which in total cost us around 5,000. We can eliminate these costs and we can use a external remote processing unit but to just send the data to the bot, with data which the bot would use to move around using IoT mechanisms. And using economies of scale, we can get low prices when we order these sensors and other things in bulk. Thank you. This project is one of our first projects. We are all first year students, and before we got into our college, we didn't know what Raspberry Pi was or what Arduino was or what any of these things were. It has been just one semester for us, and we were able to successfully learn Raspberry Pi, learn Arduino, learn all the languages required. We were able to work with image processing. We have even used machine learning and artificial intelligence algorithms in this project. We believe that this project also has immense ability to do social change. At our homes, we have so many people who are old and they need assistance. This bot has the ability to provide that assistance to them. These days, we cannot be there for them all the time, and this bot is the solution. With this project, we have demonstrated a proof of concept. When this is extracted and put in commercial production, we will be able to do immense change in the world with this. Thank you.